This lecture video table, please read the OER textbook 3. After you finish watching this lecture video, please start working on homework 4.3 as soon as possible. In the previous lecture video, we looked at how quantum numbers are related to the periodic table. And in this video, we're going to take a look at how the periodic table is organized. Okay, so pretty much the periodic table is organized into groups. The element within the same groups will have similar physical and chemical properties. And those elements also arranged in order of increasing atomic numbers or the number of protons as well from left to right. Okay. The group that that I mentioned is the column, right? So each of those columns are referred to as group of the element, and the location of each of these groups where they are in, if they are in the same group, they are going to exhibit similar physical and chemical property. And as you learned from the previous video, the rows on the periodic table, those refer to the period, right? So if I recall this or tie this back into the previous video, we know that the period will tell us about the principal quantum number n, right? The n value can be told by this. And the group is going to be the one that associates with the value of L, right? And we learned from the previous video as well, the first two groups, including the helium, okay? This would be when L equal to 0, which is referred to S block or S orbital, okay? And on the one on the far right, right, this whole groups right here, this is when L equal to 1, this refer as P block because the valence electron are located into the P block, right? And then we see in the middle, okay, so this would refer to as when L equal to 2 or the D block. And then the last one, which is these two group, these two row right here, this is when L equal to 3 or the F block, right? So we learned this before with the quantum number in the previous video. Please note that what we are going to take a look at in here is we're going to take a look at other ways or different ways to categorize this into different type of groups by using different category, and how can we group them together by looking at their properties. Okay, all right, so the first part that we are going to take a look at is how can we divide them into major division. Okay, so by using their physical properties, such as the first one would be metal. So most of metal are shiny, they can be drawn and piled, right? Without breaking. They are good conductor of heat, and also they are good conductor of electricity as well. They are solid at room temperature, most of them, except probably mercury, right? And most likely they are going to lose electron when they undergo chemical reaction. Okay. The second group on the periodic table is called nonmetals. Okay. Nonmetals are brittle, they are poor conductor except graphite. Okay, and they're present in all phases, liquid, solid, gas. Okay, and when they undergo chemical reaction, they most likely gain electrons. We're going to talk about this later. Okay, and then the third group would be metalloids. Metalloid has the property between metals and nonmetal because they're located in between those two. So if you look at the periodic table right here, you will be able to see that when we talk about metal, it's going to be the majority of the element on the periodic table that on the far left. Okay, so it's take up like majority of the element on the periodic table, except hydrogen. Okay, so except hydrogen, so note that. And then on the far right, those are the nonmetals, okay, including hydrogen as well. And between metal and nonmetal, these are metalloids. Okay, so note that when I talk about nonmetals, it's just not many at all, right? It's the one on the far right. Okay. And we can also divide the periodic table into other group as well. For example, the main group element, okay, transition metal, lanthanides, or actinides. Okay, so these are another category that we can actually break them down. So pretty much this one is going to be, so for the main group element are those S block and P block that we see earlier, right, from the previous lecture video when we talk about the quantum numbers. Okay, transition metal would be the D block. Okay, so this is D block. And lanthanide and actinide, this is going to refer to the F block. Okay, so on the periodic table, these groups are, okay, so the main group element would ranging from the 2 group on the far left and the another 6 group on the far right. Okay, so there are 2 systems that we can use to differentiate these. The system 1 is letter A, right? So group is going to range from group 1A to group 8A, or we can do group 1 to skip to 13 to 18. Okay, so that would be the 2 systems that you can use, right? So we can use either A system or the 18 system. Okay, main group elements, the reason why we call them main group elements, because these are the elements that are going to be predictable based on their location on the periodic table. What do we mean by predictable? It just means that whenever we talk about the property, for example, the size of an atom, these trend size of an atoms would be more predictable because they are going to follow the general trend. However, when we talk about the transition metal, which is the D block group, they tend to be less predictable. Okay, so that means you just not be able to find out the general trend for this. Okay, and then lactanide and lanthanide would be the 2 last group that are on the periodic table. Okay, so my expectation for you is that you will need to understand when I refer to group 1A or 7A, you need to know what they are on the periodic table, or if I refer as group 15 or 16, right, you need to know what they are. Okay, so you need to know the 2 systems. Okay, so another thing that I would like to point out would be when we talk about the main group element. Okay, when we talk about the main group element, so pretty much if you're looking at the main group element, the number of the group, number 1A, so I'm going to use the A system. Okay, so group 1A versus 2A, right? 3A, 4A here, all the way to 8A. Okay, so each of these group on the main group element, the location of those groups will tell you about the number of valence electron. Okay, so we already talked about this. How do you figure out the valence electron? You can write out the electron configuration and look at the number of electron in the highest n value. Okay, if you draw electron configuration and count the number of electron in the highest n value, you will see that group 1A would contain 1 valence electron. Group 2A would contain 2 valence electron. Okay, group 3A would contain 3 valence electron. Okay, and group 4A would contain 4 valence electron, and so on. Okay, so that means group 8A would contain 8 valence electron. Okay, so that means in this case the number of valence electron can be predicted on the main group element by looking at the number of electron in the highest n value. Okay, so that's going to be some general thing that you are going to have to know. Okay, so pretty much if you look at these, right, 8A would have 8 valence electron, and we are going to take a look at why is this important when we talk about the chemical reaction. Okay, all right, so what we are going to take a look at is that the main group element can also be broken down into smaller type of group as well. For example, group 1A excluding hydrogen, right? So these would be called alkali metals. Okay, so again, remember hydrogen is not a metal, so that's why I did not include it in here. So group 1A except hydrogen would be alkali metals. Group 2A would be called alkali earth metal, right? Group 6A would be chalcogen. Okay, so 7A would be halogen, and 8A would be noble gases. Okay, so you need to know each of these different groups, what are they located in. Okay, so if I refer to noble gas, you need to know what do I mean by that. Okay, so these are the main group elements. So why the noble gases is really important. Okay, so the noble gases have the most electron configuration. As I mentioned earlier, this noble gas here, the valence electron. Okay, so VE is the valence electron. The valence electron of the noble gas will equal to 8 electron total except hydrogen, or sorry, except helium. Okay, so all of them are having 8 valence electron except helium. Helium has only 2 electrons. So that means in this case, because their electron configuration is the most stable, their all the element on the periodic table is most likely gain or lose electron in order to achieve this, right? They want to lose or gain electron in order to have the same number of electron as the noble gas, or have the number of valence electron as the noble gas, right? Either 8 electron, and for hydrogen, it would have the same number of electron as helium, which is 2, okay? All right. So that means if you think about this, group 1A, because group 1A contain 1 valence electron, therefore in this case, in order for the group 1A to achieve the same electron configuration as the noble gas, it needs to lose 1 electron to achieve the same number of electron configuration as noble gas, right? For example, in this case, so pretty much in this case, right, so for lithium, for example, it would be 3, right? In order to accept, or if it's going to accept electron, it needs to accept 7 more, and that means it's going to have to achieve neon, right? Accept 7 more electron is going to be more difficult than just lose 1, right, in order to achieve the helium electron configuration. Okay, so same thing for potassium as well, right? If you're looking at potassium here, except if potassium accept electron, it needs to accept like, what is it, like several more, right, in order to become like krypton electron configuration. But if it's loose, it's going to lose only 1 to achieve the argon. So losing 1 is easier, right? So if you're looking at the number of electron here, okay, so, and that's going to lead to the trend of the charge for each of these group as well. If you're looking at group 2A, most likely the charge is going to become, if it's undergo chemical reaction, is going to become 2+. Skip to group 3A, right? So we are focusing on main group element right now. For group 3A, the main group element is most likely to become 3+, because it's easier to lose 3 electrons than accept, you know, like 5 more, right? So same thing here. I'm not going to talk about group 4A. The reason for that is because it's going to lose or gain, the ability to lose or gain are equal. So most likely group 14 or group 4A are not going to lose or gain electron, but they are most likely to share electron when it's undergo chemical reaction. So that's why we are going to skip that. But if you skip to group 5A, this group right here, when it's undergo chemical reaction, is most likely to accept 3 electrons in order to achieve the electron configuration as noble gas. Group 6A is most likely to gain 2 more electrons in order to achieve the electron configuration as noble gas. And group 7A would gain 1 more to achieve the electron configuration as noble gas. So again, all these charges that you see, okay, has to do with how it's going to lose or gain electron, okay, in order to achieve the same number of electron as noble gas, right? So we are going to either lose or gain in order to achieve the electron configuration as noble gas, because noble gas have the most electron configurations. Okay, note that I have not even talked about the lanthanide, actinide, or transition metal yet. The reason for that is because, again, these group are not very predictable, right? So that's why we consider these group our main group element, because they are more predictable than the transition metal. Okay, all right, so that means my expectation is if I ask you the element in the main group element, you should be able to predict the charge for me based on that location of the periodic table. Okay, so for example, which group on the periodic table is the most stable group? We just mentioned that, right? So that group would be the noble gases, right? Group 8A or group 18, right? Because they have 8 valence electron. Okay, so how do you count number of valence electron? Okay, so I'm going to say it again one last time. You can do electron configuration. Okay, so draw that out, and you are going to count number of electron in the highest n value. Okay, So if you do that, you are going to see that the number of valence electron for noble gas would contain 8 valence electron. Okay. All right, so now we're gonna take a look at group element in group 1A to 7A, excluding group 4A. You are going to have to predict the number of charges, right? So for group 1A, what should be the charge of this? It would be +1, right? Group 2A would be +2. Group 3A would be +3. Group 5A would be -3. 6A would be -2, and 7A would be -1. Okay, so this is this is my expectation. You will need to know how to predict the charge of the main group element. Okay. Now let's take a look at tie this back into specific element. So we're gonna look at rubidium, bromine, calcium, and nitrogen. Okay, so I would like you to tell me what should be the chemical symbol for ions, and also tell me the number of electron total of each ion. Okay, rubidium is the Rb, right? Oops, there is the. So I have this swap right here. So this would be, so the bromine would be Br. Okay, so nitrogen would be N. Okay, so rubidium is in group 1 or group 1A. Therefore, the charge of rubidium would be +1. Okay, so it would be Rb +1. Okay, and the number of electron after rubidium losing 1 electron, it will have 36 electron. Okay, for so sorry everyone. So actually, the one that I have to change is not the chemical symbol. Okay, so it's actually going to be the name here. So I'm going to change here since my answer are swapped right now. So can you change this to for me? Okay, so this is supposed to be nitrogen. Okay, so this would be bromine. Okay, so that way it's actually matching with my answer. All right, so rubidium, as we already see, right? So it would be group 1A, and there will be 36 electron. Now for nitrogen, if you're looking at nitrogen, nitrogen is going to be in group 5A or group 15. Therefore, in this case, in order to achieve the same number of electrons as noble gas, it need to accept 3 more. So nitrogen would be N superscript 3 minus, right? Because the superscript would indicate the charge. Okay, and the number of electron total would be, after you add the neutral number of electron in the neutral atom by 3, you are going to get 10 electron total. Okay, same thing for calcium as well. So group 2A therefore is going to lose 2 electrons. So calcium would most likely to become calcium 2+. The total number of electron would be the number of electron losing, right? So calcium has 20 electrons, lose 2 would be 18. Okay, so bromine is in group 17 or 7A. So bromine would be bromine -1. So it's going to gain 1 electron. After it's gaining 1 electron, it's going to have 36 electron total. Okay. When you're looking at the number of electron total, you will see that rubidium and bromine have the same number of electron. We call these isoelectronic species, right? Because they have the same number of electron, which is also the same as krypton as well. So that means rubidium ions, bromine ions, and krypton are isoelectronic species of each other. Okay. All right, so that's it. That's for this chapter video. Please start working on the predictable homework soon. It should not take long at all. So pretty much you are going to find out how we can categorize each of those elements into groups, and also you are going to be able to predict the charges per their location on the periodic table as well. If you have any question, please do not hesitate to reach out to me.